Hi, everyone. I have been told that I should share first now that this session has started, and I'm doing so now. So let's also full screen it. There we go. I hope everybody can see this. So, hi, and welcome to my session called How to Build Your Own Cloud Native Platform on Infrastructure as a Service Clouds in 2021. So, a single slide summary so you know what you're in for. If you have been tasked with deploying a service on just a bare infrastructure as a service cloud, which are very common here in Europe, or maybe even on-premise, you might find that that environment has tons of missing features and services that you are used to if you are more used to deploying on, say, one of the major three clouds, such as logging, authentication, monitoring services, all that good stuff that you really want to depend on in a platform, because this is dev days. So most people here are developers or connected to software development. And I'm sure that you are not really interested in just managing all the complexity of an entire platform. But the cool thing about Kubernetes is that it offers a very versatile base platform. And if you've played around with it or just looked into the material about it, you realize that it is not in itself a complete solution that works out of the box for you. But on top of Kubernetes, we can deploy some cloud native services that help you bridge the gap, which gives you a modern cloud experience, even in an infrastructure as a service cloud or on-premise. And the idea for this talk and for the demo repo that I'm posting about in the public chat right now, so you can click on it, is let's build our own. And if you use the code that is in the demo repo, it's going to set up a Kubernetes-based platform with tons of great features that I'll present about here. And it takes about half an hour to deploy the whole thing. And well, let's see what we can have from that half an hour. Okay, so about me and the company that I work for. Just quickly, my name is Lars Larsson, and you can click on my LinkedIn. I've worked in cloud since 2008, both in industry and academia. And right now, I'm a senior cloud architect at a company called Elastisys, which was founded 10 years ago. And we've always had cloud in our DNA. And now, lately, we have positioned ourselves as the makers of Compliant Kubernetes, which is a fully open source and CNCF certified Kubernetes distribution, which we also offer as a managed service. And we offer that on various cloud providers, not just the major ones, but also some European and regional clouds, but also even on-premise. So if that is something that you would rather not do yourself, but you would rather have somebody else do 24/7, you can contact us. Also, we work as consultants and training partners, et cetera, but the bread and butter really is the managed service. So, what's the problem, or if you are more of a glass half full kind of person, what's the opportunity that we are addressing here? Well, lately, GDPR and various privacy discussions have strongly moved deployment of services back to the European Union or even to on-premise installations. That is something that we especially see, of course, because of the field that we're in. So healthcare companies might need to deploy on-premise to serve the needs of a hospital system, because that hospital system might have their own data center even, and strict laws and rules and regulations about how to manage that sensitive data. And the thing is that I've noticed personally, and you possibly have also noticed, is that when you start looking around in the European Union and you start looking at cloud providers, they offer great infrastructure as a service, but it kind of stops there. So you're missing a lot of crucial services that you kind of expect these days. So you expect network security. And now I'm not just talking about like firewall rules, because they all have that. That's basically infrastructure as a service. But even simple stuff like just certificate management, you don't necessarily get that out of the box with a cloud provider here. You get that with all the major US ones like Amazon and Google and Azure. You don't really get it from European ones. Authentication, like how do I even log into this? Does everybody in the organization just get like an admin account? Are there useful audit logs? That type of thing. Storage services. I mean, there are even clouds that don't have that. Database as a service. Not everyone offers that either. I mean, the major ones in the EU, say OVH, for instance, they have it. But if you go to a random one in your home country, whichever that might be, odds are it's not going to have, say, a managed Postgres, for instance. Log handling and analysis. Since you probably have personally identifiable information in your logs, shipping them off to like logs.io, which is a US-based company, probably is in violation of GDPR. So it's unlikely that's a wise choice if GDPR is the reason why you're looking into EU-based clouds. Application-aware detailed monitoring. Maybe you can have monitoring from the virtual machine, like how much is the CPU used and how much memory is currently in use as well. But that's not really that interesting, because the metrics that you actually care about, especially as developers, as you want to understand your performance characteristics of the application that you're developing, is of course, say, how many logged in users do I currently have? Or how many requests per second am I serving? What type of requests am I serving? How far are they getting through the microservice-based architecture that I've deployed? That type of thing. That's really what you want to understand and what you really want to get some data on. Backups. Again, if there's no useful storage service, there's probably also not a backup service. I've basically never seen a container image registry service, even though Docker Hub started charging for Docker containers, for Docker image hosting now, essentially, with pool limits. Still nothing. I don't see that really in EU-based clouds. And then, of course, continuous delivery services, because all the major clouds, they have this sort of DevOps pipeline-y type of thing, like Azure or code commit and all the code named services in AWS, right? I don't see a whole lot of that going on in the EU. So, will Kubernetes come and save everything? No. And as developers, I'm sure you've heard of Kubernetes. And if your managers think that developers is now called DevOps and, hey, you should know this Kubernetes stuff, I'm not sure if everybody is super familiar with Kubernetes, but it's a great base layer to build a platform on top of. So by itself, what Kubernetes addresses is that it orchestrates containerized applications. So this is, of course, great for developers to know that, okay, if I just specify precisely what needs to go into my application, like all the dependencies, it can be packaged as a single container, and I can ship that container through testing, quality assurance, and all the way through staging and production. And it's that packaging that is unchanging, and that's what's getting deployed to production. And Kubernetes has a great way of running such containerized applications in a clustered environment. And it does so in a way that is infrastructure agnostic. So it runs anywhere. It doesn't care too much about where you are deploying, because it has all these great drivers essentially that understand what features are offered by the cloud provider, if there is one, or by the virtual machine hypervisor, like vSphere or something in VMware world, so that all you need to say is, here's an application, run it. Or this application needs to have a load balancer in front of it so that it can be exposed correctly to the internet. And it's then Kubernetes' problem to make sure that it translates that into cloud-specific API calls. So you're managing less infrastructure if you have your Kubernetes cluster set up correctly, because you don't need to care exactly how it is that you need to create a load balancer in this cloud or that other cloud, because all you need to say to Kubernetes is, give me a load balancer, your problem. However, that's pretty much where Kubernetes' responsibility stops. So it has these great abstractions. You can define what an application is. You can say, run it in this many instances. That would be called the deployment of the application. You can say, expose it as a service. You can say, expose it via a reverse proxy. That would be called an ingress. Here are some configuration values. Here are some secret values. That stuff you can tell Kubernetes how to manage, but that's where it stops by itself. But Kubernetes is extensible, and we can deploy all kinds of great services on top of it to give you a more fully featured platform. And that's exactly what this presentation is about. Because what we're doing is that we're basing it, this platform of ours, on Kubernetes as a base layer, but then we pull in software from the cloud native ecosystem and put it on top. And that's where it gets interesting. So our goal for today is a fully featured platform. And again, if you want to play along, you can look in the public chat of this Pine platform. I'm told it shows up for the people in the orange room where this talk is. So if you're listening to this talk and you click on the public tab of the chat, you should see that I posted a link there just before this talk started. So the goal for today is this fully featured platform. So Kubernetes as the base layer. And then on top, we will add network security. So firewalls and certificate management. We'll add authentication and single sign-on features so that for all the platform services that we're adding, if they have some kind of web UI, this thing will log us in. So we can use that to log in via our Google accounts. The demo repo shows how to set that up. We will install a storage service because we can't assume that those exist in generic cloud services today, even today, and especially not on premise. That's typically not at all what you get there. So there you might have bare metal servers, and you don't have like a storage service there necessarily. But the same thing also goes if you have virtual machines, just bare ones. We will install a database service via something called the Postgres operator, which means that we can easily just ask for a database to be created for us so that we have essentially the same experience as we do in, say, AWS, where we just say, let there be a database, and a whole bunch of systems take care of setting up a replicated and nicely running database for you with advanced features like point-in-time recovery all built in. We will also install log handling and analysis tools. So we're going to go with the industry standard Elasticsearch and Kibana, and application-aware detailed monitoring, a stack for that. So something called Prometheus and its viewer Grafana. We will also have a system for automated backups, container image registry called Harbor, and then something for continuous delivery, which is called Argo CD. So we will, and this all takes like roughly half an hour to install if you use the scripts that I provide you with. And It's basically, it could have been shaved off to 15 minutes. I just wanted to make it all pedagogical to show that first we install and then we add authentication on top. Really, we could have shaved it down to 15 minutes even by just doing the setup step once. So it's very easy to get started with. And what I've done in that repository is I've targeted a provider called Exoscale, which is a European cloud provider. They do have their own managed Kubernetes service. So for that particular cloud, it's quite pointless to install your own Kubernetes service realistically. But we can use it to simulate just having a very basic infrastructure as a service cloud provider. Seriously? Yes, seriously. We can set this up in that short amount of time. That's the GitHub address if you want to follow along. I'm sure these slides will be available in PDF form through the Pine platform that we're all on. And then that link will be clickable for you if you have not entered it already via the chat. And by the way, I of course appreciate if people store it and like it or whatever, but I even more than that would appreciate issues on this repo. So if you wind up using this and you feel like, hey, this thing could have been a bit better, this aspect needs improving, then write issues, because it will be so much fun to actually help people use this better. So you're helping me help others by engaging with it. So thank you if you do write issues. For instance, I know the README looks kind of ugly. That could be an issue. So the base layer of this platform, as I've said a couple of times, will be Kubernetes. Now, how do you get Kubernetes onto machines, whether they are virtual or physical, or if they're running on this cloud provider or that other cloud provider? We're relying entirely on something called KubeSpray to take care of that issue. And KubeSpray is great because it's essentially a combination of Terraform to provision your infrastructure, and then it's a huge Ansible playbook to install Kubernetes. I think it has something like 500 or something just steps that it goes through. And it sets up a production-ready Kubernetes cluster for you. And it's just marvelous at what it does, actually. And essentially, if you can SSH into it, and it's a Linux machine, I should have put that in there as well. So if you can SSH into it, and it's a Linux machine, it's probable that KubeSpray can install Kubernetes onto it. So on-premise, VMware, virtual machines, OpenStack, small EU cloud providers, it's all going to work. I'm quite sure. So as long as it's like Ubuntu or Red Hat based, perfect. Or Debian. So when we set up Kubernetes using KubeSpray, for the purposes of this demo and for this talk, we should choose a network provider, container networking interface provider that has full network policy support. And network policies, that's Kubernetes speak for firewall rules, essentially. And also, we're going to install the Nginx ingress controller so that we can expose services to the outside internet via a standardized Kubernetes API construct called an ingress. So the ingress controller is the thing that will manage the various ingresses that we will deploy. Those are, of course, chosen in the repo, and I think they're also the default choices anyways. So it's very easy to get started with that. Now, when it comes to network security and automation, what we can do is either do as in the demo repo, where we just set up a wildcard DNS entry and point it to our worker node. because that will mean that if we set up a wildcard entry for, say, example.com, anything under example.com, say demo or www or my service name dot example.com, will all just be resolved to the same worker nodes, the public IPs of the worker nodes. And then it will be picked up by the ingress controller and routed correctly in the cluster. Okay, so we can also set up something called external DNS, which, if we have a DNS provider that is supported by external DNS, it will automatically find any domain name that we try to expose services through and register those with our DNS provider. We can combine this with something called Cert Manager, which will automatically provision certificates using the Let's Encrypt service, and then also make sure to automatically renew these certificates. So they can be short-lived, which is, of course, great because that's a security best practice, and then automatically renewed when they expire. Then, of course, we also want to use these network policies everywhere so that components that are running within our Kubernetes cluster are protected. So we can say, for instance, this is the order services database. Then only the order service should be allowed to connect to it, not, for instance, the front end. And that is good for security. And it's also something that ISO 27001 recommends, for instance, because they are very keen on network segregation. So it's just a best practice, basically, to make sure that you allow traffic where it's supposed to be allowed and you disallow it where it's not supposed to be allowed. And if you look at if you want to look at the external DNS and Cert Manager combo, that's what the example here is. So as you see, the lines in bold basically say, here's a specifier. I don't know if you can see my mouse pointer. The first bold line that says Cert Manager IO cluster issuer just says that this is Cert Manager should use the production version of Let's Encrypt to get a more stable certificate. The second bolded line, the one that says host foo.example.com, says please expose it using this domain name. And that is something that external DNS will listen for and go register that domain name with your registrar. And then the block that is bolded, which starts with TLS and then has a bunch of stuff under it, that is also just to connect to tell Cert Manager where to stuff the certificate, and also the ingress where to look for it once it has been requested by Cert Manager. And that's all you need to do to register a domain name, and also to make sure you have automatically renewable certificates. So that's pretty cool. Authentication. Now, authentication is part of just sort of who gets to do what, right? So authentication is who, and then authorization is gets to do what. And Kubernetes itself has authorization features built in via role-based access control, but in order for Kubernetes to be generic, it doesn't specify a specific authentication provider. However, it does work with this standard called OpenID Connect, which I'm sure that many of you have implemented in your applications. And for the use of this cluster, we're using DEX, which is a federated identity provider that does just that. So it will be compatible with Google accounts, Microsoft Active Directory, LDAP, SAML. Well, it says it's deprecated since a while ago, so maybe not depend on it for SAML, sadly. But Google accounts and Microsoft Active Directory and LDAP, they all work great. And we can configure and use Google accounts. That's what we do in the demo repo. So it will talk to these other identity providers on one end, and then it will emit an OpenID Connect token that Kubernetes can use, but also the other services that we are integrating with in this platform. And you can see how to set this thing up in the demo repo. And if you don't care and you just want to run the scripts, then that's fine too. We might need a storage service. Now, it might seem a bit weird that we can install a storage service on our own, but that's sadly what you might wind up having to do if you have to deploy on-premise, for instance, where you just get these physical machines and some server administrator says, here, go nuts. You get to work with this. I keep these machines up and running. You do whatever you want with them. So in a cloud, we're used to having both block and object storage services. Um, Block services being virtual hard drives where you can store files, and object services being like Amazon S3, where you can store individual files and you just don't care where they wind up on a hard drive. You don't use the object storage service really as a hard drive, you use it more as a big file server. What we can do to give ourselves the support for virtual hard drives is to install Rook, which is, we can think of it as a smart Kubernetes compatible API on top of the network file system Ceph. And together, this gives us in Kubernetes persistent volume support, persistent volumes being the name that Kubernetes uses for virtual hard drives, essentially. Now, Rook could also be our S3 object storage because it can pretend to be an object storage service that behaves like Amazon S3, but I wouldn't depend on it for backups, because if you're storing your backups where your primary data is also, then it's not really a backup. It's more of a way to jump back in time. It's not really a way to actually save state in a more safe way than your original data. So that's not what we do in the demo repo. That's also one of the reasons why I'm going to talk about Velero, but it's not actually in the demo repo. Sorry. It's not difficult to set up, though, if that's what you want to do. So Ceph is great. It's a performant and very well used and known network file system. And what it will give you is the ability to just say, well, this data is important. It should be replicated in 3 replicas across this cluster. Go nuts. And that's what Ceph will then do for you. And you do this through a very simple API called persistent volume that is standard in Kubernetes. But again, something that Kubernetes itself just sort of outsources to plugins, which is kind of what Rook then is, the plugin to talk to Ceph. One thing that will store data for us is, of course, the database. Now, this being DevDays, again, I'm guessing you all use databases. I do too. But I'm also guessing that you are perhaps not super excited about managing them and dealing with all the point-in-time recovery and all that stuff that goes into a healthy database service. Now, that makes databases necessary, but perhaps not your strength. Certainly isn't mine. But I'm glad that this is such a well-known problem that there are good solutions for it. So, if you have relational data, maybe you stuff it into Postgres, or if you have MySQL data or needs for the MySQL, there's this great software called Vitess, which is the database that YouTube is running on, or at least was. Now it's open source. So what we can do inside of Kubernetes is to install something called an operator, which does the heavy lifting for us of system admin work. It will set up replication and clustering for us, do backups, point-in-time recovery, all that good stuff. And if the database becomes unavailable for some reason, and it's rather obvious how to take care of it in an automated way, the operator will do it for us. So all we need to do to get a new database is send one API object into the Kubernetes API that we have taught it to understand, and then the operator will pick it up and start doing all the stuff it needs to do to give us a database service that is according to specification. So if we want to have it replicated, all you need to do is just set one value, done. So it's kind of like the point and click experience in AWS, which is of course wonderful. Log handling and analysis. In Kubernetes, it just assumes that your logs will write to standard output. Your application will write its logs to standard output. Doesn't demand that you yourself know how to forward it to any log handling service, because that is the job of a log forwarder. So the idea is you install some software on each node in your Kubernetes cluster, and it's going to pick up all the logs that your application pods, instances, are emitting, and it's going to push it to some logging destination. And in this demo repo, we use FileBeat and Elasticsearch to do this. And then you can look at and perform analysis of these logs in something called Kibana. And if you would pay for the enterprise license, you could integrate it with an OpenID Connect provider like Dex. But of course, this being a demo repo, we can't really do that. So if you want to look at your logs, you have to use something called port forwarding in Kubernetes. But you can access the logs that way at least. And then, of course, you can, if you want to limit who gets to do that, you can do that via role-based access control and say, well, this user can't do this port forwarding, or these users can. So you can still protect your Kibana. It's just going through the Kubernetes API then, which will be the only way to actually access it. So that's pretty good. Now, I did say, and this might, of course, be of interest to application developers, that there is application-aware detailed monitoring. So the monitoring stack of choice for Kubernetes in 2021 is Prometheus, which is a monitoring system that pulls data from various sources, and then Grafana to visualize that data. And Prometheus has this concept of exporters. So something that will export data in a format that that Prometheus will understand. And it's very easy to create that for your own application. And then all you need to do is you need to update those values, and Prometheus will go and scrape your application every, well, it's configurable, but say every 15 seconds or so, so that you can keep track of these values. And we can install both, and we can integrate them with Dex so that it's easy to control who gets to see what in Grafana, because maybe I, as a system admin, should be allowed to see all kinds of dashboards, but maybe developers should only be allowed to see, I don't know, the dashboards that relate to their particular application for whatever reason. Not everybody needs to see everything, maybe. Regarding backups, persistent volumes, which again are sort of your physical your virtual hard drives, they have important data on them. So backups is of course the thing that you want, and there's a piece of software called Velero that can handle that for you. So all we need to do is install Velero and tell it where to store the backups. And as I said previously, it's not done in the demo repo because we don't depend on an external S3 service, but any S3-like object storage service will do. So you can just tell Velero, like, hey, I want you to do backups of this every 24 hours or whatever, and it's going to just do that for you. So it's very, very easy and convenient to use. Once you've built a container image, it needs to be pushed somewhere. So it needs to reside in a registry. And what we use in this demo repo is something called Harbor. And it offers not only a secure and really smart registry, but it also integrates with vulnerability scanning features. So when you say in your Docker file, I'm guessing many of you Dockerize your applications. So when you say in your Docker file, like from Alpine something, right? So from some kind of base operating system, then you install a bunch of software on it, maybe some libraries. Then maybe you pull in your requirements, whether it's like Python requirements, or Node JS or Java, jars or whatever. You probably depend on a lot of you probably have tons of dependencies in your application. And then, of course, you pull in your application code and you build it all, and then you deploy as little as possible of these dependencies, of course, and your built code. And that's what you wind up with in your container image. Now, it's your code, of course, but that's on top. Underneath, you have all these dependencies, you have that base operating system, and all those probably, most of them are open source, but they probably have uh, more users than you. And if so, there might be known vulnerabilities, and all that winds up in databases that can be queried by this tool called Trivy that integrates with Harbor. And Harbor will then show you Trivy's analysis of your container image. So Trivy will scan your container image and say, uh-oh, you're using this and this version, which has known vulnerabilities in it. So please, you need to update. Okay, so what we can do is we can set up Harbor. We can integrate it with Dex, and that means that we can control who gets to log in, who can view, who can push, who can do all that fun stuff. And that also lets us look at these reports. And you can tell it to continuously scan, because maybe there's a long-lived microservice that you're not really updating that much, and say that it's been just untouched for a month. Maybe it has vulnerabilities, not in your code, but in code that it depends on. And it's very nice to get that kind of immediate feedback from a system. And then, of course, continuous delivery. So as application developers, we love to be able to just write our code and just send it off via a Git push. And it's wonderful to just get easy integration testing, easy deployment to stage, something that will just let us approve to push out to production. And Argo CD does just that for us. And of course, that has a web UI, so we can integrate that with Dex. So again, we can use, say, our Google account to control who gets to actually do the final push to production, to approve it. So with all this stuff in the platform, you can go do great things. And essentially, if you started when installing this, when I started talking, you'd already be running this thing. It's that fast. So, summary of the talk you just listened to. This repo will give you a fully functional platform. It's fully open source, fully based on Kubernetes and cloud native tech. And no matter where the cloud that you're deploying to is located, because it doesn't even need to be a cloud. It could be on premise. You can go and get that demo repo code. If you're not deploying to exascale, which again, of course, is just an example, the only place you need to change in is in the folder called cluster, because that's where it chooses where to deploy. So fork it and make it your own by pointing to the cloud or otherwise environment that you need to deploy to. And we've used centralized authentication using a federated identity provider for all operator-facing services and for Kubernetes itself, which is not just great for security and stuff, but it also makes audit a breeze. And shameless plug, if you think this stuff is interesting, you can also look at Compliant Kubernetes, which itself is also fully open source, comes with more than this already included, but set up in a much better way. And we offer it as a fully managed service as well. So if that stuff interests you, you can go to compliantkubernetes.io, where you will find, among other things, this image, which shows the stuff that we put into it. So how that project was born was that we realized after countless customer engagements that, okay, GDPR, the Californian Privacy Act thing, and also various regulations that are industry specific, they all kind of point to the same set of controls. That is, stuff that in ISO 27001 terms would be, so they specify a process that you should have, good processes around access control, logging, network security, and all that stuff. They never say exactly use this piece of software because that would make that standard outdated quickly. But we make very opinionated choices here so that we can offer a platform that helps you address these processes using tools in as good a manner as possible. And you'll recognize that a few of the things that I've talked about now are, of course, also part of compliant Kubernetes, but notable differences being that, well, backups, they are, of course, included. Elasticsearch, since we offer this as a service, is not the now impossible to host as a service due to a license change. Elastic Search, it's going to be open distro for Elasticsearch and OpenSearch soon. And we also have Open Policy Agent running, protecting you against misconfiguration, and also intrusion detection system called Falco from Sysdig. Otherwise, it's very similar, but it's set up in a way so that, for instance, we have tamper-proof logging, which is something that ISO 27001 certification just loves. Right. So, are there any questions? Because I see that we are in the final minutes of this talk. If you do have a question, then please use the Q&A feature of this Pine platform. You have it probably on the right-hand side. I'm not sure. If you don't have any questions, ooh, doesn't having a 500-step Ansible playbook imply that the underlying technology is a bit too overcomplicated in and of itself for average projects? On that note, thoughts on projects like K3s.io. So K3s.io is something developed by Rancher, which is a highly opinionated Kubernetes distribution that is a certified Kubernetes as well. There are conformance tests so that you can say whether your distribution is a Kubernetes or not a Kubernetes, and K3s is a Kubernetes. What they target is simpler setups, like edge location setups. So it makes certain choices technology-wise that Kubernetes has not made, so that it fits into smaller virtual machines. So less resources, but it also means that instead of having a distributed database that can survive the outage of one node quite easily, it instead uses SQLite to store stuff. And the 500-step Ansible playbook, well, I mean, it does sound sort of complicated, I understand, but it's also about taking a bare virtual machine that just had Ubuntu installed on it, installing all kinds of components, securing them, and making them production ready. So I think the fact that it's divided into 500 steps is perhaps something that sounds complicated, but I'm also very happy that they do it. So when would I recommend going with vanilla Kubernetes and when with compliant Kubernetes or manage on some of the EU-based providers? Well, I think that you have to think about, is managing a Kubernetes cluster really part of what I should be doing? So a vanilla Kubernetes cluster that you manage yourself, is it in your organization's best interest to spend time on doing that? So if you also need to have this cluster up and running 24/7, that probably means you have to pay people extra to stay up or to have like on-call duties during the night. And honestly, I think that if you think about, okay, we're a development company, we develop software, managing Kubernetes is not really part of our core business, then I think that you should consider other options, especially because we can manage also the worker nodes. Now, bye. The session will end now, apparently. All right. Thank you.